What is a quadratic sequence? Well, first let's remember what a linear sequence is. A linear sequence is a sequence where the difference between the terms in the sequence is the same. For instance, consider the sequence 5, 8, 11, 14, 17. To get from term to term, you plus 3 each time. So the difference between the terms is the same and it's a linear sequence. Now let's look at quadratic sequences. A quadratic sequence is a sequence where the difference between the differences is the same. What does this mean? Let's look at an example. Consider the sequence -2, 2, 10, 22, 38. First we work out the differences between the terms. To get from -2 to 2, you plus 4. To get from 2 to 10, you plus 8. To get from 10 to 22, you plus 12. And to get from 22 to 38, you plus 16. We can therefore see that this is not a linear sequence, as the differences between the terms is not the same. But now let's look at the difference between the differences. So to get from 4 to 8, you plus 4. To get from 8 to 12, you plus 4. And to get from 12 to 16, you plus 4 too. Therefore, the difference between the differences, or the second difference, is the same. Therefore, this is a quadratic sequence. The nth term of a linear sequence looks like an plus b, where a and b are numbers. For instance, the nth term of our sequence here is 3n plus 2. If you're not sure what the nth term means, or you're not sure how to find the nth term of a linear sequence, I would suggest pausing the video and watching the video on how to find the nth term of a linear sequence first. Remember, this nth term, this 3n plus 2, is a formula for finding any term in the sequence. For instance, the first term, where n equals 1, you calculate by doing 3 times 1, which is 3, plus 2, which is 5. Likewise, the fourth term would be given by doing 3 times 4, which is 12, plus 2, which is 14. And using this, you can calculate any term, the 50th term, the 100th term, whichever term you like. The nth term of a quadratic sequence, however, looks like an squared plus bn plus c, where a, b, and c are numbers. So the nth term of a quadratic now involves this n squared term, which wasn't in the nth term of a linear sequence. For instance, the nth term of this quadratic sequence example here is 2n squared minus 2n minus 2. If you like, you can check that this formula gives all of these terms by substituting in the correct n values. Just as before, you can use this to calculate any term you like in the sequence. If you wanted the 40th term, for instance, you could substitute into this nth term n equals 40, do the calculations, and you'll end up with the 40th term in the sequence. How do we go about finding this nth term for other quadratic sequences? Let's find this out using an example. Say you're asked to find the nth term of the sequence 4, 11, 24, 43, 68. Before we begin, we should check that this sequence is a quadratic sequence. So we need to check that the difference between the differences is the same. If we first work out the differences between the terms, well, the difference between 4 and 11 is 7. So you add 7 to get from 4 to 11. 11 to 24 is plus 13. 24 to 43 is plus 19. And from 43 to 68, you plus 25. So we can see that this is not a linear sequence, as otherwise these would all be the same. Now let's work out the differences between the differences. To get from 7 to 13, you plus 6. To get from 13 to 19, you plus 6. And to get from 19 to 25, you also plus 6. So the difference between the differences, or the second difference, is the same. Therefore we know that this is a quadratic sequence. Now we want to find the nth term of this quadratic sequence. To do this, I have a helpful guide. Here we have a set of 4 different steps we need to follow in order to find the nth term of a quadratic sequence. Let's go through it step by step. So step number 1 says find the difference between the differences. So we've already done that. We found the difference between the differences is plus 6. For step number 2, we divide this difference by 2 and we multiply it by n squared. 6 divided by 2 is 3. Multiplying this by n squared, we get 3n squared. So what we're going to do is we're going to write a final answer box down here. And in our final answer box, we're going to write the 6 divided by 2, which is a 3. Multiply it by n squared. So we've got our 3n squared as part of our final answer. So we now know what the n squared term is in our nth term, but we're still missing some other terms that we need to work out. For step 3, we make a table. The table we need looks like this. It's going to have 4 rows. In the top corner we write n, and then we write 1, 2, 3, 4. This stands for the first term, second term, third term and fourth term of our sequence. We actually know 5 terms of the sequence, so we could add a 5th column here, but it's a bit quicker if we just use 4 in our table. In fact, we could only use 3 terms up here, but I think 4 makes it clearer. Next here we write term. In the third row, we write the part of our final answer that we've already calculated. So the difference divided by 2 times n squared, our 3n squared here. And on the bottom row, we write term minus whatever we wrote here, so our 3n squared. So you will need to remember this table format. The table's always going to look like this, apart from you place 3n squared with whatever you've already put in your final answer box here. To fill this in, so the term when n equals 1 is 4. The term when n equals 2 is 11. When n equals 3, 24. And when n equals 4, or the fourth term, 43. It then tells us to calculate 3n squared. So here we want to write 3n squared when n equals 1. So that's going to be 3 times 1 squared. We know that 1 squared is just 1, so 3 times 1 is going to be 3. Here we want 3n squared when n equals 2. So we're doing 3 times 2 squared. 2 squared is 4. 3 times 4 is 12. Here we want 3n squared when n equals 3. So we want 3 times 3 squared. 3 squared is 9. And 3 times 9 is 27. And finally, here we want 3n squared when n equals 4. So 3 times 4 squared. 4 squared is 16. And 3 times 16 is 48. I've done those calculations quite quickly. If it's helpful, you could write down what the n squared values are for these terms first. I've done these calculations quite quickly, but if you want to avoid making mistakes, what you could do is write down the calculations in a bit more detail on the side of your paper. For the final row, we want the term minus 3n squared. So that means for each column here, we're doing the second row minus the third row. So term minus 3n squared here, so we've got 4 minus 3 is 1. 11 minus 12 is minus 1. 24 minus 27 is minus 3, and 43 minus 48 is minus 5. You might notice that in our final row we've created a linear sequence, the sequence 1, minus 3, minus 5. This is a linear sequence as to get from term to term, you minus 2 each time, so the difference between the terms is the same. This brings us to step 4, where we have to find the nth term of this linear sequence. If you like, we can treat this as a sort of sub-question and forget about the original question for the moment. Now our focus is on finding the nth term of this linear sequence here. To help us with this, I've got this guide from a previous video, how to find the nth term of the linear sequence. Let's work through the steps here. So, first of all, we find the common difference. We've found that the common difference is minus 2. We then multiply it by n. So at the bottom here, we sort of have a final answer to our mini sub-question. So the common difference is minus 2, we multiply it by n, minus 2n is part of our answer here. We make a table. This table looks a bit different to the quadratic sequences table, so it's really important to not get confused. If you have to memorise these procedures for an exam or something, it might be a good idea to make a poster of what the tables look like for linear sequences and quadratic sequences and put them around your house to help you remember them. So for our linear sequence table, we have 3 rows this time. We write n here, 1, 2, 3, 4. In this box here in our second row, we write the part of our answer that we currently have, so the difference times n, minus 2n. And then we write term at the bottom. Then we fill in the table by calculating, so minus 2n when n equals 1, that's going to be minus 2. Minus 2n when n equals 2, minus 2 times 2 is minus 4. Minus 2n when n equals 3, minus 2 times 3 is minus 6. And finally we have minus 2 times 4, which is minus 8. We then write in the terms of our sequence, so our sequence here is 1, minus 1, 1 minus 1, minus 3, minus 5. And then we work out what we add or subtract to get from this second row to the third row. So here, minus 2 to 1, we're adding 3. Minus 4 to minus 1, we add 3. Minus 6 to minus 3, we add 3. Minus 8 to minus 5, we add 3. So actually, in fact, this whole second row we add 3 to get to the third row. So in our linear sequence answer, we add a plus 3 here. So we've found the nth term of this linear sequence. So we can go back to our quadratic sequence finding steps. We've completed step 4, finding the nth term of this linear sequence. And then what we do is we fill in our answer here in our final answer box. So we've already got 3n squared, and then we simply put this answer next to the 3n squared. So we put minus 2n here, plus 3. And that is our final answer. It's always a good idea to check that our final answer is correct by checking this nth term formula with the terms of the sequence that we know. For instance, if we substitute n equals 1 in here, we should get the first term of the sequence here, 4. We can try that. So when n equals 1, we have 3 times 1 squared, which is just 1, minus 2 times 1, plus 3. Put the squared here. So that equals 3 times 1 squared is just going to be 3. 2 times 1 is 2. So we've got 3 minus 2 plus 3. And this equals, so 3 minus 2 is 1 plus 3, which equals 4, which is exactly the answer we wanted. In an exam, you might want to check with one other n value, for instance, n equals 2, so you just substitute in n equals 2 here and see if you get 11 as your answer. Let's try another example. How about finding the nth term of the sequence minus 4, 3, 12, 23, 36? So once again, we should check that this is in fact a quadratic sequence. So let's work out the differences between the terms here. So minus 4 to 3, u plus 7, 3 to 12, u plus 9, 12 to 23, u plus 11, and 23 to 36, u plus 13. So it's not a linear sequence, otherwise these would all be the same. If we work out the differences between the differences, so 7 to 9, we have plus 2, 9 to 11, plus 2, and plus 11 to plus 13, we plus 2 again. So you can see that the difference between the differences, or the second difference, is the same, so therefore we have a quadratic sequence here. Let's now follow the steps on our quadratic sequence guide. So first step, find the difference between the differences. We've done that, it's 2. Second step is divide the difference by 2 and times by n squared, which we're going to do, and we're going to put it straight in our final answer box. So we have our difference 2 divided by 2, which is just 1, and then we're timesing that by n squared. So we're going to have 1 times by n squared here, but we can just write that as n squared. So 1 times n squared is just n squared, and we write that in our final answer box. Step 3 is we make our table. So this is the table where we have 4 rows. We have n here, 1, 2, 3, 4. Again, you could have more n values at the top, and you could have as few as 3, but I think 4 is quite a good number. Here we write term. Here we write in what we have in our final answer box already. So we have the n squared, and then we write term minus n squared. So filling this in, our first term, so when n equals 1, we have minus 4. When n equals 2, it's 3. N equals 3, it's 12. And when n equals 4, it's 23. In this row, we fill in n squared, which isn't too bad. So we just have 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. Then here, we're doing term minus n squared. So the second row minus the third row. So we've got minus 4 minus 1, which is minus 5. 3 minus 4 is minus 1, 12 minus 9 is 3, and 23 minus 16 is 7. Once again on our final row, we see that we've created a linear sequence because to get from each term to the next, we plus 4 each time. So this should always produce a linear sequence, this process. If it doesn't, it therefore means you've probably made a mistake doing your calculations somewhere in this table. So we now progress to step 4, which is to find the rule for the nth term of this sequence here. So we can do that in a little separate section here because we're sort of answering a separate question. So we want the nth term of this sequence here. So as we're finding the nth term of a linear sequence, we can use our nth term of a linear sequence guide. Step 1, find the common difference. We've found that, that's 4. Multiply it by n. So here in our little answer box for this sort of sub-question, we're going to write 4 multiplied by the n, 4n. We now make the table for the linear sequence, which is a bit different. So we're writing n, 1, 2, 3, 4. Bottom row we write term here. In this middle box here we write in the part of the answer we already have, so 4n. We then fill in these rows, so 4n when n equals 1, 4 times 1 is 4, n equals 2, 4n is 8, 4 times 3 is 12, and 4 times 4 is 16. We then put in the terms, which are the terms of this sequence here. So that's minus 5, minus 1, 3, and 7. We then, in step 4, work out what we add or subtract to get from the second row to the third row. So to get from 4 to minus 5, we're subtracting 9. Likewise, from 8 to minus 1, we minus 9. 12 to 3, minus 9. And 16 to 7, again, minus 9. So to get from the second row to the third row, we're subtracting 9 each time. So therefore, we write minus 9 here. So we've completed finding the nth term of this linear sequence, so we can go back to finding the nth term of our quadratic sequence. So we've done step 4, and now all we do, we write in our answer here for the linear sequence in the box next to what we already have for our quadratic sequence. So our final answer for our quadratic sequence is going to be n squared plus 4n minus 9. And that's our answer. Once again, let's check this. So we can check this using any of the terms we have. Suppose we substitute in n equals 3. So we secretly know that this should give us 12, as that's the third term. Let's see if it does. So we have 3 squared plus 4 times 3, or n, minus 9. And that equals 9 plus 12 minus 9. The plus 9 and the minus 9 cancel out, so we're just left with 12 here, which is what we were aiming for. So that gives us a good indication that we've got the correct final answer. Let's try one final example. How about the sequence 110, 100, 80, 50, 10? So once again, we need to check that this is in fact a quadratic sequence. So here the difference is minus 10, 100 to 80 is minus 20, 80 to 50, minus 30, and 50 to 10, minus 40. So we know we don't have a linear sequence, as otherwise these would all be the same. So we've tried to find the second difference now, the difference between the differences. Minus 10 to minus 20, u minus 10. Minus 20 to minus 30, minus 10. Minus 30 to minus 40, u minus 10. So we know that we have a quadratic sequence, as the difference between the differences are the same. So now we can refer to our quadratic sequence guide. Step 1, find the difference between the differences. We've done that, it's minus 10. Secondly, we divide by 2 and times by n squared. And we're going to put this in our final answer box, so let's write that here. So in our final answer box, we're going to write the difference between the differences, minus 10, divided by 2, so that's minus 5. And then we times that by n squared. So far we've got minus 5n squared in our final answer. Let's head to step 3. We make our table, so we've got our 4 rows. We've got n, 1, 2, 3, 4. Here we write term. Here we write what we already have in our final answer, minus 5n squared. And then here we write term minus 5n squared. So we're minusing what we have in our second row, but we need to be really careful because this second row is negative now. We have minus 5n squared. So if we're doing minus 5n squared, that's going to become a plus 5n squared here. Filling this table in, well, for the term row, when n equals 1, the term is 110, n equals 2, 100, n equals 3, 80, and n equals 4, the fourth term is 50. Now we need to calculate minus 5n squared, so here we're going to have minus 5 times 1 squared, which is going to be minus 5 times 1, which is minus 5. Here, when n equals 2, minus 5 times 2 squared, which is minus 5 times 4, so minus 20. Then minus 5 times 3 squared, which is minus 5 times 9, which is minus 45. And finally, minus 5 times 4 squared, minus 5 times 16, which is going to be minus 80. Again, I've done these calculations quite quickly, so when you're doing this, feel free to take it more slowly and write some rough workings on the side of your paper to make sure you get the correct answer. For our final row, we're doing this row minus this row, and we need to be really careful with the negative signs here. For instance, here we're going to have 110 minus minus 5, which is going to be the same as 110 plus 5, which is 115. Here we have 100 minus minus 20, which is going to be 100 plus 20, so 120. Here 80 minus minus 45, so 80 plus 45 is 125. And finally 50 minus minus 80, so 50 plus 80 is 130. Just as before, we now notice that this final row is actually a linear sequence. To see this, we can work out the differences between these terms. So to get from 115 to 120, you plus 5. 120 to 125, you plus 5. And likewise here, we also plus 5. So as always, we've ended up with a linear sequence in this final row. So we now progress to step 4, which is finding the nth term of this sequence. So let's draw a box here where we're going to work this out. So we want the nth term of this sequence here. And we can now bring on our linear sequence guide. So step 1, find the common difference. We've found that, that's 5. We multiply it by n, and we're going to put that in our answer box. So we've got 5 times by n. We then make a table. So again, this is different to the quadratic table, so you need to be careful. So this table has 3 rows. We have n. Here we write the part of the answer we already have, so 5n. And then we write term. And here we write 1, 2, 3, 4. 5n, so 5 times 1 here is 5, 5 times 2 is 10, 5 times 3 is 15, and 5 times 4 is 20. And then we fill in the terms of this sequence here. So that's 115, 120, 125, and 130. So we've done steps 1 to 3. We now work out what to add and subtract for step 4. So to get from 5 to 115, you add 110. To get from 10 to 120, you add 110. And hopefully you can see that for all of these, you add 110 to get from the second row to the third row. So we can fill this in here next to our current answer. So we've found the nth term of our linear sequence. We then go back to our quadratic sequence card. And so we've done step 4 here. So now we fill in this answer in our final answer box. So we're going to add 5n plus 110. So that's our final answer. Once again, let's do a check. So let's try when n equals 1. So when n equals 1, we're going to have minus 5 times 1 squared plus 5 times 1 plus 110. So that's going to be minus 5 times 1 squared is 1, so that's just minus 5, plus 5 times 1, just 5, so minus 5 plus 5 plus 110. Minus 5 and the plus 5 cancel out, so we're just left with 110, which we can see is correct. So we can be confident that we've got the right answer. So you now know the difference between linear and quadratic sequences, and how to find the nth term of a quadratic sequence.